Hi, my name is Jackie Ashley and I'm a Senior Regulatory Specialist at the British Columbia Utilities Commission in Canada. Today I will be presenting my paper titled Effectiveness and Balance, a Canadian Regulator's Approach to Review of Energy Efficiency Funding Proposals. And please note that my paper and this presentation represent my own personal views and do not represent the views or opinions of the BCUC, nor do they express any opinion on pending or future matters before the BCUC. I would like to start by ensuring we all have the same definition of success when it comes to the electricity market. I think you will agree that markets are only efficient when you have an efficient supply side and an efficient demand side. With electricity markets, however, sometimes there can be too much focus on lowering the cost of supplying electricity and not enough on reducing waste. However, isn't the goal of an efficient electricity market for customers to have the heat, light and power they need at the lowest overall cost? So if it's cheaper to install an efficient light bulb than to supply the electricity that would otherwise be wasted, shouldn't we do that? Now, this way of thinking can change our definition of success. If we only focus on the supply side, our focus is just on selling electricity, and success is reliable service provided at low rates. However, if we have a whole of the market approach, then success is instead providing the heat or light the customer needs at the lowest overall cost. Customers in jurisdictions with this whole of the market definition of success will pay less for the light and heat that they receive than customers in jurisdictions that only focus on the supply side. Once we have established the definition of success as promoting both the efficient supply and use of electricity, the next big question becomes, how do we know whether it would be better for a utility to invest in new generation or encourage a customer to reduce waste? Before going into the cost-effectiveness tests, I would like to also address concerns that are sometimes raised that a utility is in the business of selling electricity and so would not have an incentive to encourage a customer to reduce waste. However, regulated utilities are different from normal companies. In their case, the regulator determines which costs they can recover and how much profit they can earn. Where it is cheaper for the utility to meet customer needs through energy efficiency programs rather than new supply options, the regulator can not only ensure that the utility recovers the cost of its energy efficiency programs, but can also provide them with the financial incentive to run these programs effectively. So how do we know where energy efficiency programs are more cost-effective than supply-side options? One attempt to demystify the various energy efficiency cost-effectiveness tests is by looking at the question from the perspective of effectiveness and balance. I will provide a brief overview of these 3 steps now, then go through them in more detail. Step 1. Is there a problem with how electricity is being used by a customer? For example, is it being wasted? Step 2. If yes, is it cheaper for the utility to fix this problem by nudging the customer into changing their behaviour, or to continue to supply the electricity that's currently being wasted? And lastly, we would look at the effectiveness and equity considerations in deciding which problems to fix. So the first step is to determine if there is a problem. Where are customers being inefficient in their investment or consumption decisions? For example, having old inefficient lights or motors. The study that asked this question is called the Conservation Potential Review, and the test is called the Total Resource Cost Test or Societal Cost Test, depending on the inputs used. The Step 1 test determines if there is a problem and is a cost-benefit analysis. The first part is costs. The cost here is the cost of the customer's investment before any incentives. You'll be looking at the cost to the customer of replacing, for example, an old inefficient ceiling fan. On the benefit side, we will be looking at the value of energy saved. Now, this isn't the reduction in electricity on the customer's bill, but instead is the value of energy saved to the utility, including any network losses or reduced network capital costs. It can also include any emission reduction benefits or non-energy benefits. For example, the new efficient fan might be quieter than the old fan, and that may provide an additional benefit to the customer. If the benefits exceed the costs, then we have identified that there would be an overall benefit to society from nudging a customer to change their behaviour. Once we determine that there is a problem, for example that the customer should replace their old fan with a more efficient one, the next step is to determine whether the utility can cost-effectively fix this problem. It is important to address this additional test, as not all problems are cost-effective for the utility to solve. This requires 3 steps. The first is to identify the reason why the customer is not making an efficient decision. For example, why are they not replacing their old inefficient fan with a more efficient model? Examples of market barriers could include high upfront cost. The customer might not be able to afford the cost of a new fan, even though it would save them money over the long term. Barriers could also include a lack of information or lack of time. Once you have identified the market barriers, the next step is to design programs to nudge the customer into changing their behaviour. For example, nudges could include giving the customer cash incentive to install a more efficient fan. It could also include customer education programs or working with retailers to ensure that the more efficient fans are being stocked. Programs could also include assisting local governments in putting in place new codes or standards, for example those that require the building of more efficient homes. The last step is to then determine whether the cost of the energy efficiency program that you have designed is cheaper than the cost of supplying the electricity that would otherwise be wasted. This step is called the utility cost test. In this test, the cost is now the cost to the utility of nudging the customer to change their behaviour. This would include the cost of any incentives provided to the customer and the administration of the program. For the benefits, this will include the value of energy saved to the utility as before. However, there are some nuances to this calculation. There may be some customers who participate in an energy efficiency program when they would have, for example, installed an efficient fan anyway. These customers are referred to as free riders, and the energy associated with estimated free riders should be deducted from the total energy savings estimated to result from the program. The other side of this is when a customer undertakes an energy efficiency investment as a result of an energy efficiency program, but without directly participating in it. For example, where the new product becomes business as usual, and this estimated spillover effect could act to increase the estimated energy savings. So these 2 steps should help identify cost-effective energy efficiency programs that nudge the customers into reducing their waste of energy. But how do you know which programs to include in an energy efficiency portfolio? This issue is addressed in this 3rd step of effectiveness and balance considerations. All customers pay towards the cost of energy efficiency programs, so all customers should have the opportunity to participate. Effectiveness considerations include prioritising low-cost energy efficiency programs. However, this is not the only consideration. Other effectiveness considerations include minimising lost opportunities. This is where, if we miss an opportunity to nudge a customer into making a more efficient investment decision now, it could be much more expensive to do so later on. Examples here could include new home construction or factory retrofits. Programs that encourage market transformation can also be effective, even though they may be more expensive in the early years when the technology is new. The final part is balance considerations, which looks to ensure that all customer classes have a reasonable opportunity to participate in energy efficiency programs, in particular for hard-to-reach customers, such as lower-income customers and renters. It's important not to discount programs that can have significant benefits, such as education programs, just because their energy savings can be hard to measure. In BC, utilities are required to offer educational programs and programs specifically targeted at low-income customers and renters in their energy efficiency portfolio. In summary, I believe that energy efficiency programs can be a low-cost way of meeting India's energy needs, and I hope that this effectiveness and balance approach can assist utilities or other energy efficiency providers in securing the funding that they need. Thank you very much for listening to me today, and if you want to know more, I encourage you to read my paper which provides additional details. Thank you.